Okay, we're continuing the comparison tests, the direct and the limit comparison test. And let's take a look at 35. Still, nope, no, it's the next page, 765. And we have the sum from 1 over n factorial, n equals 1 to infinity. Okay, I'm sure you remember that n factorial is n minus 1, n minus 2, dot, 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 multiplied by 3 times 2 times 1. It turns out that if we replace all these terms by something smaller, right, by 2 to n minus 1, 2 times 2 times 2 times 2 times 2 times 2, and so on and so forth, then 1 over n factorial will definitely be smaller than 1 over 2 to n minus 1, which is basically geometric with a common ratio of 1/2. So the sum of 1/2 to n minus 1 when x goes from 1 to infinity is convergent. By the direct comparison test, the sum of 1 over n factorial, n equals 1 to infinity, is also convergent. Okay, let's move on to 37. Same page, 765, and we have the sum, n equals 1 to infinity, sine 1 over n. Very good hint, 1 over n, we know it's harmonic and divergent. And now let's apply the limit. As n approaches infinity, always this at the top, always this in the denominator. And let's see what we get here. Remember, n approaches infinity really means 1 over n approaches 0. And we had in Calc 1 the following limit. Limit of sine of a box over the box when the box approaches 0, and this is 1. And this is exactly what we're using here. This and this and this are all the same. And the box approaches 1. Or the square approaches 0, I meant to say. Okay, so therefore the answer is 1. This number is greater than 0. We used a series that is divergent, so is this. So then therefore the sum from n equals 1 to infinity from sine 1 over n is divergent by the limit comparison test. Let's look at the last one, 41. Use the sum of the first 10 terms. So we are looking at S10 for same page, 765. From n equals 1 to infinity, from 1 over 5 plus n to the 5th power. I meant to write. Good. So they want us to use S sub 10 to approximate the sum of the series. Okay, and then estimate the error. Good. So what we're going to do first is look at Bn, which is 1 over n to the 5th, because we know that, remember the requirement, is my requirement at the beginning to estimate. I have to have positive terms and we have to have a convergent series. Okay, this is convergent as a p series with p equals 5, as we know. So therefore this is convergent by the direct comparison test, because we are comparing it to 1 over n to the 5th, and y, again, let's write it down. So 5 plus n to the 5th. this is definitely less than or equal to 1, because this is a bigger denominator, so it has to be a smaller fraction. So by the direct comparison test with this that is the bigger and is convergent, then the smaller one has to be convergent by the direct comparison test. Okay, in the next step, we know that the remainder of this with 10 must be less than or equal to the remainder, oops, I meant to write t, the remainder of this with 10. So then, first, we will determine, a quick refresher why we're doing this. Remember, the remainder Rn was less than or equal to, in this case, so we have 10 here, so this will be S10, so this is 10, this is 10, plus the integral from n to infinity from f of x dx, and of course this will be 10. Okay, so what we need to determine is we need to find this. Okay, because this is the error. This is easy to determine with a calculator. But they're only asking us to find the error. So let's find just the error. Good, so then the error would be, let's find first n to infinity from 1 x to the 5th dx, which is limit as t approaches infinity from n to t, x to negative 5 dx, which is the limit t approaches infinity, x to negative 4 over negative 4 from n to t. Negative 1/4 outside, limit t approaches infinity, 1 over t to the 4th minus 1 over n to the 4th. Well, but this approaches 0, and the answer would be 1 over 4 n to the 4th. We will plug in 10. So from here, 1 over 4 times 10 to the 4th, I got approximately 0.00025. Thank you, and I hope this helps.